Hey guys, welcome back to my channel. In this video, we will be mainly talking about some examples related to beams. So let us get started. So the first example here is that a beam 6 meter long is loaded as shown in figure. We need to determine the support reactions at A and B. So this is our figure like this. So what we need to find here is that to hold this beam intact, there will be a reaction force. These are the reaction forces which are like this and this. Okay, and these are the forces which is applied on that beam. So if you are calculating the summation of vertical forces, let us consider this as RA and this as RB. So we'll have RA minus 4 minus 6 plus RB is equal to 0. From that we'll get RA plus RB is equal to 10 Newton. Similarly, we can find the summation of MA. So summation of MA here will be equal to minus 4 into 2 plus minus 6 into 4 plus 4 into 6. Okay, sorry, here there is nothing, so it will be RB into 6. From that we will get the value of RB to be 5.33 Newton. We know that RA plus RB is equal to 10 Newton. From that we will get the value of RA to be 4.67 Newton. Okay, so the next problem, a beam AB of span 12 meter. Span is the distance from this point to this point, 12 meter, shown in figure, is hinged at A. So hinged is something like windows, so it will be moving, it won't be having any horizontal force, or it will only be having this vertical force. Okay, so and on rollers on B, we need to determine the reactions at A and B for the loading shown in figure. So we are consider this as A and this as B. Okay, so what we'll do here is that first we need to draw the diagram. So there is no diagram here given here, no, so we'll just draw the diagram here. So these are the forces which are acting. So there will be two reaction forces on the hinge A, and there will be only a vertical force in the hinge, that roller B. And these are the forces 10 Newton, 15 Newton and 20 Newton respectively. So in the case for an equilibrium state, summation of H, summation of V and summation of M should be equal to 0. So if you are considering summation of H is equal to 0, we are having HA, this one, plus minus 15 cos 30, then minus 20 cos 45 is equal to 0. So from that we will get the unknown value HA to be 27.13 kilonewton. Similarly, we can do summation of V is equal to 0. So we have VA minus 10 minus 15 sin 30 minus 20 sin 45 plus BRB is equal to 0. From that we'll get the value of VA plus RB. So we'll get the value of VA plus RB from this. Then we'll do the summation of MA. Summation of MA here will be minus 10 into 4 minus 15 sin 30 into 6 minus 20 sin 45 into 6, 10, then RB into 12. Okay, so these are the moment, and if you are equating it to 0, we'll get the value of RB also. Then from RB we can find the value of VA. Now if we are getting VA also, now we can calculate the value of RA. From that we get Ra to be equal to 29.898. Then we can calculate the alpha also. Okay. Let us move to the third question. So in this question we need to determine the support reactions at A and B of the beam shown in figure. So this is our beam here. So we need to find this. If we are considering this as A and this is as B, so this will be having RA and HA. It will be having a horizontal force like this and also a vertical force like this. And here also as this is a roller, it will be only having this vertical force as it can't move in this side because it's restricted. So if we are taking summation of V is equal to 0, we have this VA. We are considering this force as VA minus 4 minus 6 plus RB. We can consider it as VB also, it's your wish. Since it is only one force, we can consider it as RB. So we get VA plus RB is equal to 10 Newton. Then summation of MA is equal to 0. If we are considering that, we have minus 4 into 3 minus 6 into 7, then 12 into RB. From that we'll get the value of RB also, then we can get the value of VA also. It's just the same kind of question which we did earlier. Now let us move to the fourth question. In this we need to find the reactions at support S, supports A, B in the beam AB shown in figure. The beam AB shown in figure. So I think this is our diagram here. So we have a 30-degree angle here, then this force is like this, then another force like this, then we have another force, then here we have a hinge, here we have a roller. So we need to find the reactions. Reactions implies that we need to find the vertical force like this, the horizontal force VHA, then here we need to find the RB value. Okay, so to find these values, what we will do here is that we will draw the free body diagram. So here we have VA, then we have HA, then we have 60 kilonewton 60 degrees, then 80 kilonewton 75 degree, then we have 60 degree like this, then we have RB. Why is this angle 30 degree? It is just because if you are considering this angle like this, we are getting alternate angles, so that is why we are saying this angle is 30 degree. So what we here we need to find VA, HA and RB. So if you are considering summation of MA is equal to 0, that is if you are considering the moment from this point A, then we have we don't need to calculate this HA and VA. So it will be only we can find the unknown value RB easily. That is why we are taking the point from MA. So we'll be having RB sine, uh, you can take cos 30 or sine 660, it is just the same, into 1 plus 2 plus 2.5 plus 0.5, which is 6. So which is 6. Then we have minus 50 because it is in downwards direction, and minus 50 sine 60 into 5.5, minus 80 sine 75 into 3, minus 60 sine 60 into 1 is equal to 0. From that we'll get the value of Rb to be equal to 100.4475 kilonewton. And now as we have got Rb, now we can find the value of Va. So Va we can calculate it by using the summation of V is equal to 0. So we have V minus 60 sine 60 minus 80 sine 75 minus 50 sine 60 plus Rb sine 60 Rb cos 30 is equal to 0. We know the value of Rb. From that we can find the value of Va. So we can get the value of Va, and to get the value of Ha is also the same property. After finding everything, we can find the value of Ra. Ra is the resultant of Ha and Va. Then we can find the angle also. Okay, so angle also we can find. Let us move to the next question. So a beam AB, the beams AB, CF are arranged as shown in figure. We need to determine the reactions at A, C and D due to the forces acting on the beam shown in figure. So the beams AB and CD, AB and CF are arranged as shown in figure. So this is our beam AB and CF is this angle. We need to determine the reactions at A, then C, A, C, D due to the forces acting on the beam shown in figure. So first of all, let us just draw the forces acting. So here we will be having a vertical force, then we will be having a horizontal force, then here also we are having a VC, then we are having an HC, here we are only having a VD. Okay, is that it? Is there any other forces? Now if you are considering summation of MA is equal to 0, we are having RE into 3. What is RE? It's this force. Okay, so Re into 3 minus 20 into 3, because this is 1 meter, then here we have another meter, so totally it will be 3 meters. So 20 into 3 minus 40 sine 45 into 4, because this angle is saying about this angle, it is equal to 0. From that we will get the value of Re. Then we can find the summation of V is equal to 0. If we are taking summation of V is equal to 0, we have VA plus RE minus 20 minus 40 sine 45 is equal to 0. So we will get another value, which is VA is equal to minus 9.428 kilonewton. Then we can find summation of H also. Then we can find Ra, then alpha also in that manner. Now if we are considering the beam CF, we will consider the moment from point C. So we are having minus 20 sine 60 into 1. Okay, minus 57.124, which is Re, into 2, minus 10, because we are having a moment in the anti-clockwise direction. Okay, this is actually plus 10, because it's in the anti-clockwise direction. Then if we calculate the value of RD, we get 40.451 kilonewton. Then summation of H is equal to 0, then we get HC is equal to 10 kilonewton. Then summation of V also we'll get VC is equal to 34.1178, and RC we get 35.5531, and we get alpha 2 is equal to 73.66 degree. Okay, so let us move to the sixth example. We need to find the reactions at A and B. Okay, so we need to find the reactions at A and B. So I think B is this part because it's not given anything. So let's name it as. Now if you are drawing the free body diagram, we have HA in this side, VA in the vertical side 3 meters, then we have a moment in the clockwise direction, then another 2 meters, then we have 30 kilonewton downwards at angle 45 degree, then we have RB which is 1 meter away, then we have minus 40 kilonewton which is 1 meter away. So in these cases what we do is that we take the moment first, summation of moment first, because from we can isolate these two values and just find the value of RB. After finding RB, it is simple to find the value of VA and HA. Or else if you are finding the values of summation V and summation H, there will be a lot of unknown values. That is why this we are taking summation of MA first. So here we have the thing here. Then summation of MA is equal to 0. So summation of MA is equal to minus 40 into 1 plus 2 plus 4 plus 3, which is equal to 7. So we have minus 40 into 7. Then we have RB into 6. Then we have minus 30 sine 45 into 5, that is this. Then we have a moment in the clockwise direction, so we are taking minus 40. Now if we equate it to 0, we get the value of RB to be equal to 71.011 kilonewton. Then we can find the value of summation of H is equal to 0. Then here we have HA minus 30 cos 45 is equal to 0. Why? Because as you can see here, we have one horizontal force HA and the other is 30 cos 45 into 30 cos 45 in this direction. So if we equate, we get the value of HA, then we'll get the value of VA, then we can find the value of RA, then we can find the value of alpha. It's just the same thing. We are just doing it again and again. And I forgot to tell you about this. This is a uniformly distributed force. That means it is distributed on each side equally, which is equal to 20 kilonewton. Now if you want to convert it to a single force, then we just need to multiply the area. So it will be 20 into 2, which is 40 kilonewton, and we should keep it as the middle of this of this 2 meter, which is 1 meter. Okay. Now let us move to the seventh question. In this question also we need to find the reactions that supports A of the loaded beam. So here we have a roller, here we have a hinge, then we have a uniformly distributed this, then we have 60 kilonewton and everything. So if we draw the free body diagram, we are having VA 20 downwards, 20 downwards, 60 downwards, VB upwards, then we have HB, and we just need to calculate these values and we can find the answer. And then in this problem also it's just the same thing. We have in this case it is a constraint, like it is supported only on this part, so it will be having both vertical and horizontal reactions. So if you just know that about that, we can solve this problem easily. Okay, so we can find it. Now this problem is a little bit different. We need to find the reactions at the supports of the loaded beam here. So if you look at this beam, this is actually triangles. That is, it is uniformly varying forces acting on this thing, this supports. So here we have a roller, here we have a hinge, and this force is acting in this manner. So if we are considering from this part, we can consider we should find the area of this triangle, that is this triangle. Okay, if you are considering the area, it will be half of 1 into 10, so it will be 5 kilonewton. Okay, so it will be 5 kilonewton, and it will be kept one third of this from this thing. Why? Because uh, the centroid of a triangle, right angle triangle, will be 1 by 3 of from the uh, angle. So it will be 1 by 3 from the 90-degree angle, and 2 by 3 from the small angle. So it is, that is why it is kept like this. Then considering this triangle, this triangle is also a uniformly varying force system. So in this case also, first we need to find the area of this triangle, which is 10 into 2 into half. So it will be 10 kilonewton. And in this case also, if you are considering this right triangle, this is the 90-degree angle. So this should be kept 2 by 3 from this point, so it will be 2 by 3 of 2. Okay, 2 by 3 meters from this point, 2 by 3 of 2 meter from this point. Okay, so we'll get that. Then here we have another triangle. Here it is actually a triangle and a square also. So first we will consider this triangle. So we can calculate it as half of 10 into 3, so we get 15 kilonewton. Then we can calculate 3 into 10, which is 30. So we can just draw it in this manner also. Okay, then we can find the summation of MA, then summation of PA, then we will get the value of RB. Okay, now let us move to the last question here. So in this question, we need to find the reactions of the supports. So here we have a hinge, here we have a roller, and here we have force like this. So if you are drawing the free body diagram, here we have HA, here we have VA, 5, 4, 8, and VB. Now if you are taking summation of MA, it will be minus 5 into 2 plus 4 into sine 45 into 4 VB into 8. And we are not considering this part because it is a horizontal force. So we will get the value of VB first we will get the value of VB. Then if you are taking summation of HA, we have HA plus 4 cos 45 into 4, and similarly we can find the summation of V also, and from that we get the value of VA to be 2.33 kilonewton. Okay, so that is all of this beam works. So in the next video we will be talking about friction problems. So I'll see you in that. Thank you for watching.